Welcome everybody to my session about serverless architecture and how we can use this to enhance our Kubernetes workloads. I'm waiting for my slides to pop up and then we'll kick it off. Oh,
sorry.
Here we go. So, short introduction about myself. I'm Remon from Harmelen. I'm a cloud architect currently working with Qualcomm in Ireland. My expertise areas are Azure, cloud migration, data engineering, and Kubernetes. I specialize in designing and implementing complex data solutions in Azure. I'm currently 4 months engaged and probably be engaged for another 3 years before we get married, knowing ourselves. I'm a fanatic with Dungeons and Dragons, currently hosting my own adventure. And I try to play a lot of games, but most of my time goes into deep diving YouTube tunnels. As you can see here in this slide, I have a QR code. That's the link to my LinkedIn page. This is not only important if you want to connect with me, but if you have any questions after this session, you can contact me on LinkedIn. Because I'm not able to join the speaker's corner after this talk, this would be the best way to reach out to me. Before we start with the fun part, let's go over what you can expect from this session. So in today's session, we're going to deep dive into the world where serverless computing meets Kubernetes. So here's what's in store. The basics, don't worry, I'll try to keep it as fun as possible. It's a quick rundown on what serverless computing is. Spoiler alert, there are still servers involved. The essentials of Kubernetes without the overwhelming jargon. Then we're going into the fun stuff, the hands-on, setting up a local Kubernetes environment using Kind that won't destroy your laptop, hopefully. We're gonna deploy OpenFaaS. This will be our bridge to between serverless and Kubernetes. There are multiple tools that you can use for this, but OpenFaaS is just the one I picked for my demo. Building an actual working serverless function. It's going to be a simple dictionary app that actually does something useful. We're going to test it both through the command line and a nice web interface. So what you'll take away from this, hopefully, is an understanding how to create serverless functions without getting locked into specific cloud vendors. Practical experience with tools you can use immediately after this session, ideas on how this approach might solve problems in your own projects, and a new perspective on cloud architecture that blends the best of both paradigms. So whether you're a Kubernetes pro curious about serverless, a serverless fan wanting more control, or just a cloud curious enthusiast, there's something in the session for you, I hope. I've designed this demo to be accessible while still showing real-world techniques. No heavy lectures. We're going hands-on with real code and real deployments. By the end, you'll have seen a complete workflow from setup to deployment to testing. So let's get started. So let's start first with some theory. I promised to just keep it at the basics. So what is serverless? Despite its name, serverless doesn't mean there are no servers. It means that you as a developer don't have to think about them. With serverless computing, the cloud provider handles all the serverless resources. Or if you do serverless on-premise, the platform team is responsible for your infrastructure. You as a developer don't have to care about it. You only pay for what you actually use, not what you think you might need. Your code runs in containers that spin up when triggered by events. So why do people actually love it? No server headaches. Forget about setting up, scaling, or maintaining servers. The infrastructure just works for you. Pay only when used. If your code isn't running, you're not paying anything. Great for the CFO. Grows automatically. Your app scales up and down instantly based on demand, handling anything from a few requests to a few thousands per second. It ships faster. We as developers can focus on writing business logic instead of wrestling with our test servers, our test environments. It works on my computer kind of stuff. So what are some common use cases for serverless? Think about API backends, processing data and data files, responding to events from other services, and running scheduled tasks without a dedicated server. Are there some common pitfalls that you should watch out for? Yeah, think about cold starts, delays when functions haven't been used recently, time limits on how long a function can run. You don't want your function running 48 hours because then the CFO is not happy anymore. need for external storage since functions are stateless, more complex debugging across distributed components. So overall, serverless is and was a game changer for the cloud computing. It shifts focus from managing infrastructure to pure application development. While not perfect for every situation, it lets many teams innovate faster with less operational hassle. Think of serverless not as no servers, but as servers that don't get in your way. So for the second part of this session, we need to talk about Kubernetes. Kubernetes was created by Google based on their experience running containers. It helps you deploy, scale, operate application containers across a group of computers. Think of Kubernetes as the operating system for your data center or cloud. It lets you treat a bunch of machines as one big computer. There are some few basics that you should know about Kubernetes. So the cluster and nodes. A cluster is a collection of computers, and each computer is a node. They all work together, and each node can run multiple containers. Then you have the smallest piece of infrastructure in Kubernetes, pods. Pods are like tiny units of work that group containers that share resources. They come and go as needed. Then you have your services. Services make your apps accessible, providing stable networking and spreading traffic evenly. And last but not least, deployments. Deployments let you describe what you want your app to look like, and Kubernetes just makes it happen. Then, why do people actually love Kubernetes? It handles the tedious stuff. Kubernetes automates deployment, scaling, and fixes issues with manual intervention. Without manual intervention, my apologies. It works anywhere. Develop on your laptop, deploy to any cloud. The underlying infrastructure doesn't matter. It grows with you. It scales up and down easily, either manually or automatically based on demand. It fixes itself. When things break, Kubernetes just restarts the container and replaces the failed components. What are some common use cases? Running lots of small independent services, working across multiple cloud providers, running scheduled computation jobs, running databases with persistent storage. There are some challenges with Kubernetes. It can be complex to learn. It needs its own resources to run, so you typically need your own infra team to run it, to support it. Monitoring distributed systems takes specialized tools. Think about Prometheus. Azure Monitor nowadays helps as well. Kubernetes has become super popular because it solves real-world problems when running containerized apps at scale. While it adds a lot of complexity, the benefits outweigh the complexity for most teams. So just remember, it's not always the right tool for every job, but if you have a complex system, it could be a great foundation. So from there, we're going into a demo. What we're going to use today is Kind. Kind is a tool that lets you run Kubernetes clusters inside Docker containers on your local machine. Kind stands for Kubernetes in Docker. Think about it as a mini Kubernetes playground that runs on your computer. Instead of needing actual servers or cloud resources, Kind creates a virtual Kubernetes nodes as Docker containers. Why use Kind? It's perfect for testing and development. It's very lightweight. It runs on my desktop. It closely mimics a real Kubernetes environment, and the best thing is it creates and destroys my cluster within seconds. So it's a great way for learning Kubernetes without getting actual costs. Then I'm going to add a local Docker registry. And that's like having your own private version of Docker Hub running on your computer. When you build your container image for your applications, instead of pushing them to the public internet, you store them locally. This is typically faster. I can work offline, and it keeps your development code private, especially if you see my code. I want to keep it private for multiple reasons. I'm not the best developer there is. It's perfect for testing before sharing publicly. So I'm going to use a script. I'm going to show you the script in just a second. This script is developed by Kind itself, and it's available to download on their website. I will also share a GitHub repository after this session where you can find this script as well that you can use. So this script automatically sets up both a Kind cluster and a local registry that work together. This means you can build your container image on your machine, store them locally, and then deploy them to your local Kubernetes cluster without ever needing an internet connection. While I say that, that's a lie. during the initial setup of this, it needs an internet connection to pull the images to your machine. But after that, you don't need it anymore. So it's basically setting up a complete self-contained Kubernetes development environment right on your Windows machine with Docker Desktop. Just a small thing to make this work. You need to open your Docker Desktop, then go to Settings, Docker Engine, and you need to add this line of code. So you need to add insecure-registries, localhost, port 5000. If you want to use that port, if you want to use a different port, you can do that. But if you don't add this, Docker Desktop doesn't know you use a local registry. So from here, let's start with our first deployment. So let's run the script. It's going to be kind, and then I'm going to tab with registry.sh. It's going to run. As you can see, it's pulling the node image, making sure it has the last one. It's preparing our nodes, then it's writing our configuration. Now it's starting our control plane. This can take a little bit. So now it's installing our CNI and installing a storage class. One of the benefits is that it automatically sets up our context to be kind, so I don't have to adjust that context anymore. It knows I'm working with this environment. So one of the other things that I need to do is I need to make sure that our Docker environment is running correctly. So it's running, so now we can actually start. So we have our local Kubernetes cluster up and running, so let's deploy OpenFaaS services. To support our functions. OpenFaaS is an open source framework that brings serverless capabilities to Kubernetes. It simplifies the deployment process by letting you package code or existing applications as serverless functions without worrying about the underlying infrastructure. OpenFaaS handles the complex parts of Kubernetes for you, so think about providing the autoscaling, the metrics, and the intuitive developer experience through both its UI portal and CLI. It effectively bridges the serverless and Kubernetes, giving you quick deployments and event-driven benefits of serverless while maintaining the Kubernetes benefits of flexibility and avoiding vendor lock-in. With OpenFaaS, you can run your functions on any Kubernetes cluster, so it can be the kind that we're using. Think about Minikube if you have that installed on your own PC. Think about AKS, ECG, whatever Kubernetes cluster you want. It runs on it. For today's demo, we'll be using Arcade to install OpenFaaS. Arcade is essentially an app store for Kubernetes. It's a command line tool that makes installing Kubernetes applications way simpler. Instead of having to apply multiple YAML files or follow a complex installation procedure, Arcade lets us deploy OpenFaaS with just a single command line. It handles all the dependencies and configurations behind the scene, so we can focus on building our serverless functions rather than wrestling with setup details. And also, I don't have a platform team behind me to install my Kubernetes, so I need to do it myself. So I want to keep it as simple as possible. So we're going to do Arcade install OpenFaaS. As you can see, it's now quickly installing it for us. This will take a few seconds if everything goes correctly. So let's hope the demo gods are with me. So it's now installed. So before we can continue, I need to make sure that everything is up and running. So we're going to get our pods and we're going to use the namespace. No, I need to add a space there and go to OpenFaaS. So as you can see, the alert manager is already up and running. The gateway, we're still waiting on that. The NAT is already up and running, and Prometheus is still what we're waiting for. The most important part for this session is we need the gateway to be up and running. So let's see if it's up and running now. As you can see, it's there. So now that we have OpenFaaS installed, we need to talk about templates. OpenFaaS uses templates. They are the magic that powers OpenFaaS functions. Think of templates as a pre-built apartment where your code gets to live. So what makes the template special? Templates provide the foundation for your functions. They are reusable starting points that handle all the boring infrastructure stuff, while you can focus on writing actual logic that matters. It's like having a professional kitchen already set up where we can just walk in and start cooking. OpenVAS offers templates for practically any language you want to use. Think about Python, Node.js, Go, you name it. Each template comes with everything your function needs to run properly in Kubernetes. So what's happening under the hood? So OpenVAS has something called watchdogs. They are specialized web services that handle the communication between the outside world and your function. There are two main types, the classic watchdog and the off watchdog, the newer, faster version that we'll be using today. Now, the real power of OpenVAS is in the Docker file, the heart of each template. This Docker file determines how your function gets packaged, where your code lives, and how requests flow through your function. So, as we start, let's have a look at what's in the store. So we're going to use the fast CLI. Then we're going to go to template store and list all the possibilities. So as you can see here, we already have some downloaded that come with the installation of OpenVAS, and we have some that we can still add to our environment. So as you can see here, we have Java, Node, PHP, Rust, COBOL for the people that still want to use COBOL. For today's session, we're gonna focus on Python. So to download the latest template that we want to use is, I'm gonna use template store, pull Python 3-Flask. With this command, I'm gonna pull everything that's underneath Python 3 Flask. So that also means I'm getting Debian, HTTP Debian, Flask Debian, Python Flask, and Python 2.7 Flask as well. So now we got everything to start our actual build, actually start the fun stuff. But before that, let's go into the anatomy of everything. I'm going to open my Visual Studio now. As you can see here, we have an extra folder, a template folder. We're going into one of the folders. And I want to talk a bit about the index.py. The index.py is the command center of your application. It serves as the entry point for all incoming requests and routes them to your function. Then we have requirements.txt. This is, think of this as your foundation layer. It contains all the core dependencies needed to run a Flask application itself. So in here, we'll see Flask, Waitress. Waitress is production grade WSGI server, and Tox as well with a version behind it. Then we have the template. It's the blueprint, like a template says, containing all deployment specifications. It tells OpenVAS how your function should be configured when it goes live. Then if we go into the folder function, we have another requirement.txt. As you can see, this is empty. This is your function's personal shopping list. So any special libraries that you need or tools that your specific function needs should go in this file. This is where we'll add our dictionary module in a bit. Then we have the Docker file itself, the central environment. I don't want to install Docker in my Visual Studio Code, so ignore the pop-up. This is the recipe that transforms your code into a container image. It contains all the instructions for building a complete runnable version of your function, ready to deploy to Kubernetes. So understanding all these pieces is actually what gives us the power to customize any aspect of the function's environment. For now, we'll just focus on editing just what we need, but remember that all of these components are there to be tailored to your specific requirements. So let's start with a simple application. We're going back to our bash. So now comes the fun part. It's time to build our serverless function from scratch. For this demo, we're going to create a practical tool that you might actually use. I would actually use it, a smart dictionary function that looks up word definitions for us on demand. Rather than just returning a hello world, our function will tap into a linguistic database to provide real definitions when you send it a word. So let's use a template we just downloaded to scaffold our new function. The fast CLI makes this incredibly easy. So we're going to use fast CLI new. We're going to call our function PyDictionary. We're going to use the language Python 3. Flask, and then Debian. I need to double check because my typing skills are not the best, so make sure that I didn't make any typos. So as you can see, it created a function in a folder. It also created a stack file. These two are very important, so let's go over them one by one. So I'll go back to Visual Studio Code. We're going to close this one. As you can see, we have a new folder here, PyDict. We're going to open that one. And we're going to open our requirements because we have a requirement for our script. We want to add, oh, I actually need to select it, NLTK. So this is giving our function the linguistic superpowers. We're adding the natural language toolkit library. So that's NLTK is this 3.8.1, and then we're going to save. Make sure you save because I typically forget that and then nothing works. It happens. So now let's go into the brain of our operation, the actual functional code. For this, we need to open the handler.py. As you can see, it already has an example code in it. We're just going to delete everything. We don't want to use that. I'm going to copy paste a piece of my code. Give me a sec. I'm not going to type it all out because then we're here for the next 10 minutes with my typing speed. I'm going to save it. So don't worry if all this code details don't make any sense right away. The important thing that you need to understand is that this function takes a word as input, downloads the WordNet dictionary data if needed, looks up all the possible meanings of the word that we gave him, organizes the definition by part of speech. So think of noun, verb, etc. And it returns the structured results as a JSON. So, and just like this, we created a powerful serverless API that can provide a dictionary definition on demand. No servers to manage, no complexity infrastructure, and just a function itself. So, we've been talking about Kubernetes. And if you talk about Kubernetes, then no journey is complete without diving into the world of YAML. But don't worry, FastCLI has made this very easy for us. It has done most of the heavy lifting. We just need to adjust some small things. So we're going to open stack.yaml. And as you can see, it's already filled in. This is our travel itinerary for our function. It tells OpenFast everything it needs to know about how to build, deploy, and run our code. So let's take a closer look how this is built up. So as you can see here, there's a gateway configuration. The gateway settings point to where OpenFast services live. Since we're testing this locally, the default setting works perfectly for us. In a real-world cloud deployment, you to replace this with an actual gateway address. Then we have our function definitions. So under the function section, we register all serverless functions we want to deploy. You can have multiple functions in a single YAML file, perfect for deploying related services together. Then we have the details. So for each function, we specify the language. So which language template do we want to use? The handler, where to find our code. Image, where to store the Docker image. So as you can see, it's going to PyDict playlist, but it doesn't know where we want to get it from. So I need to make sure to tell it that we are going for a local host, colon, with port 5000, and then /. Remember what I told in the beginning. You need to add this line here in your Docker desktop. You need to make sure that the link is the same as here, because otherwise it will never know where to push your image to. So this tells OpenFast to store and retrieve our function image from the local Docker registry that we set up earlier. The beauty of this approach is that the same configuration would work for any registry. You can just replace this. So to actually start this, we need to do some extra work. We need to create a bridge between our local machine and our Kubernetes cluster. Remember the gateway I just showed you that we mentioned in our YAML file? We need to make it accessible. So first, let's make sure that everything is running correctly. So that's kubectl get service.m openVAS. So here we can see we have the gateway. That's our most important service at this moment. You can also see that our gateway uses port 8080. We need that in our next command. So what we're going to do now is we're going to create our tunnel from my machine to the Kubernetes cluster. So we're going to use kubectl port forward as we're forwarding the port /n openVAS svc typo gateway 8080 is 8080. Let's see if I didn't make any typos. So now it's opening the tunnel. This is like building a secret passage between our laptop and our Kubernetes cluster. Even though everything is running locally, Kubernetes maintains its own internal network. So port forwarding lets us access the services inside of that network as if they were running directly on our machine. So as I'm hosting the port forward, the tunnel on this terminal, I need to create a new terminal where we can continue with our environment. So let's start with the fun stuff now. What we're going to do is we're going to run this command that transforms. Let me actually finish typing because I can't think about two things at the same time. So this command transforms our Python code into a container image, complete with all the dependencies and configuration it needs to run. So what we're going to do is fast CLI, build, and make a build out of the stack.yaml. I, of course, need to go to the correct environment, repos, and then navigate. So now it's building our container image. So this takes a few seconds, maybe a bit longer. If you want to go through this, please run it on your own PC. I really don't want to go through it. It's way too much information. And it should be done. So now that our image is built, let's try to push it. So fast CLI push stack.yaml. So now we're going to push it. So prefix. Why is this not working? This should work. Give me a second. It's always fun. A live demo. You must provide a username or registry prefix of the function image. Did I miss something? Let me. I'm trying. Let's have a look here. Did we actually save? Oh, it's open stack image name is open. That's the wrong. Yeah, PyDig latest. This should work. So our tag doesn't exist. Let's have a look. Localhost PyDig doesn't exist. Error could not execute command docker push. Let's try it without the tag then. Give me a sec. Always good to know. This was working yesterday. I think you didn't save the file, yeah? That's okay. Close, close, close. live troubleshooting. Docker. Yes. Registry is up and running. Is this still working? Yes. I also see I only have 10 minutes left. So let's see if I can try to fix this quickly. Stacked with YAML, it's provider name, openVAS, yeah, this is the right location, localhost. Let's have a look. So I tested everything yesterday, but I moved the location from where I was doing stuff to my new environment. And let's have a look. So error could not execute command, docker push, and the push refers to repository local, yeah. Tag does not exist. So it sees it as a tag. So let's try our build command again. So, and in our YAML, double check. That's there. And let's add our registry as well, just to localhost.
Hi, Remon.
Hi.
Just a quick reminder, you think you didn't save the stack YAML beforehand, and then you build it with the wrong tag, so maybe
I think so as well.
Save and build again, and now it should work, I think. When the build is running through.
The build is just done, so let's see.
Yeah.
This is why live demos should always be done with four people.
Yeah, that happens. Yes. Keep going.
So I'm starting to sweat here. I thought everything was working. So now we uploaded our image to our local repository, making it available for deployment. OpenVAS has some security, so we need to actually get a password. So I'm going to copy paste this line of code because it's way too much to type, and also the time limit. So it created a code. Now I'm going to give it to my environment, which is a grep. So, and now we're going to log into our OpenVAS because we're slowly getting to the most important stuff. So we're now going to deploy it. So let's do OpenVAS CLI deploy /f stack.yaml -t and then http, not s 127. Yeah. Sorry, don't press enter in your numpad area. 8080. You're not using encryption connection. Yeah. So now it's important to say, are we still? Yes. Look up. So this is why I typically paste commands. I make a lot of typos. So as it's now accepted, we are going to do a quick test as we only have 4 minutes left. So the quick test will be to do an echo of a word. Let's use brevity. It should now give us the nuance, the use of brief expressions, and the attribute. Now I'm going to quickly go to my browser because I still want to show you the CLI, the web interface. So I know my password, my user is admin. I created a password, but I didn't accept it or visualized it. So I'm going to do that now. Quickly copy paste it and sign in. No, I don't want to save my password. Here we have the web interface. We have PyDict, our function running here. We can give it a request. So let's use paradigm. And then invoke as a text. And as you can see here, it gives within seconds the answer. So this portal makes it easy to test and monitor all your functions in one place, perfectly for sharing with team members or demoing your work. I'm going to cut it short off here because we only have 3 minutes left, and I think we should use that for QA. I'm going to share a repo in the chat that where you can find all this information that we just did during the session, and all the extra information I was going to talk about as well. This is my repo. It's going to be added to the comments. Hopefully I can do that. So Maximo Matthias, if you could do that. And once again, the QR code of my LinkedIn page if you have any questions that we don't get to answer right now.
Yeah, thank you for your talk. Thanks for the live demo. It's always a bit stressful, but I mean, you did well. Some many things are always happening. Yeah, cool. So I just sent the link to you to the repo into the chat. Have fun. You can look at it. Yeah. So we saw in the list of the possible functions that COBOL is also an option. Did you ever try any of this? So like, I mean, we can build host systems with scale to 0 now, or?
I have never used COBOL, to be perfectly honest. I know it's, especially in the Netherlands, it's a dying language. It's maintained only for a few banks. Would I run a scale to 0 environment with COBOL? No. Perfectly honest, no.
Yeah, that was kind of a fun question, but it's interesting that it should work in this setup too. Could be a nice tool to migrate from COBOL as well.
Yeah, true. Yeah, and a really exotic architecture in this case. We use COBOL to build functions as a service.
Yeah, true.
But also, especially with almost, I think 60% of the banking system still runs on COBOL. So maybe we don't want to do that, because I would like to receive my payments.
True, yeah.
Very nice that you set up Kind for that, to show it locally. I was curious, is it also possible to use Kind with other environments? Because you showed us Docker Desktop to use it. Is it also possible to use Rancher Desktop or Podman to use Kind?
Oh, I typically use it with Docker Desktop, but I can check it and just answer the question later. I know it supports a lot of stuff, but I don't know exactly what. I just use it with Docker Desktop.
Yeah, understandable. I was curious because Docker Desktop is now priority. No.
So licensed.
Licensed, right? And therefore, some people have to look for alternatives.
But OpenFaaS, which is the framework you used, is open source, I guess?
Yeah.
Okay.
Yeah, and also, if you want to go if you don't want to use Docker, I typically use Minikube to test a lot of stuff, because you can use your Windows Hyper-V environment. So ignore the Docker part. So maybe use that. Yeah. I like that question in the chat. What's your opinion on OpenFaaS versus native? And I would even say versus Knative. Just to keep it interesting. I would say Knative makes Kubernetes act as serverless functions. Knative is what I think is the future, personally. OpenFaaS is, I really like the ease of use for it, and native is more enterprise ready, in my opinion. It supports more, it's more stable than what I would use with OpenFaaS.
Yeah, okay.
But I like that question. And overall, I would, if I'm hosting my own Kubernetes cluster, for example, in Azure or Amazon, I would probably use Knative.
Okay. Another question, if someone already has serverless functions at some cloud providers, how hard is it to migrate from these existing functions to OpenFaaS?
Ooh, so this is one of the fun parts. It all depends. This is the most consulting answer I can give. It all depends. So it depends on all the requirements you've built in to your environment. AWS Lambda and Azure Functions, and I forgot what Google called them again, but they all have their proprietary environmentals. So you need to bring that back to your on-premise cluster or your cloud cluster even. But it is possible as long as it's, let's say you use OpenFaaS and you have a function, an Azure function that is just a Python script. The Python script can easily be copied as long as you fill in the requirements.
Yeah. Okay. There was another. Sorry.
Sorry, I'm Martin. I'm probably butchering your last name.
The question too, yeah.
Community-wise, what's the largest? This is a guesstimate, but I would say native.
Yeah, I would.
At the moment.
I would guess too, but it's only a guess, yeah.
Yeah, it's a guesstimate. I don't have the numbers, but I would say I've heard more about native than OpenFaaS or Knative at the moment.
Yeah. So, do you know from any cost perspective whether some Kubernetes-based serverless approach against the traditional cloud provider serverless offerings, which one is more cost-effective, so to speak?
Cost comparisons are always very interesting because it's never a simple answer. It's not a straight, this is cheaper. Yeah. It's like asking whether it's cheaper to buy or lease a car without knowing how much you're actually going to drive the car. Mm-hmm. So let's put it like this. Cloud provider serverless offerings shine in a pure pay-per-use model, which, especially when you spike a lot. An on-premise Kubernetes model is more of a stable, like we run them a lot. So they are more stable in less spikes. I would go for that. Mm-hmm. So typically what you see is if serverless is done correctly, you see it drop to around 40% in cost. But this is if you do it correctly. Mm-hmm. One of the biggest things is that this is why I also recommend if you are going into serverless, talk to cloud experts as well. Because serverless, if you do it incorrectly, it's going to increase your cost by 60%. So this is cost comparison. It's difficult, I would say.
Yeah. So, but I think the OpenFaaS approach is more or the better choice if you already have a Kubernetes cluster, nevertheless, and don't start with serverless functions just right now. Yeah. So then you can reuse the existing resources, right?
Yes, but once again, don't focus on OpenFaaS. You can use native on your on-premise cluster as well. Yeah. Use any FaaS tool to do that because it's already being paid for. I don't know about other companies, but I know companies that do internal billing as well. So they have one large cluster running on-premise and they bill each department for the use. So that's where serverless could be useful to make sure that you don't get billed so much internally.
Yeah.
But that's indeed like, do you want to get into serverless? You already have a Kubernetes running. Go for a fast solution on Kubernetes. Yeah. Are you looking to not be vendor locked by Azure, for example? Yeah. Go for a fast solution. That kind of stuff.
Yeah. Yeah.
And especially nowadays, now multi-cloud is actually a bigger thing than single cloud.
Yeah. Okay. Yeah, nice. Then thank you a lot for your time and your demo and the introduction to Kubernetes-based serverless functions. Nice that we had you here. Will you meet in the Speaker's Corner afterwards?
No, I won't be able to as other appointments. But once again, scan the QR code. If you have any questions, reach out to me. If you want to talk about D&D as well, reach out.
Nice. Okay. Yeah, no problem. But anyone else that has meanings or questions or just want to talk about serverless functions, feel free to nevertheless join the Speaker's Corner and just chat with each other and have a nice little chat there. Yeah. Okay. Thank you, Remon, for your time, and have a good day.
Thanks, and have
See
a great
you.
day. Enjoy the
Bye.
sessions.
Yeah. Thank you.